Hi everyone, welcome to our second lecture of CSE307 this semester. Today we are going to cover Python and SML. So we are going to learn one of the most modern programming languages, Python. Currently it's the most popular programming language. It's used in biomedical informatics, physics, and many other areas. Including computer science, web development, even implementing the kernel for certain programs. So again, if you log into your Blackboard for CSE307, Principles of Programming Languages for the summer 2018, you can follow the link to the class webpage to get access to the lecture notes for today. So today, as I said earlier, we are going to talk about Python. We are going to do experiments with Python. At this point, I think most of you, if not all, already installed Python on your machines, because homework number 1 was all about installing several programming languages that we are using in this class. So the easiest way to start with Python is to install the default Python installer and use the idle debugger and idle graphical interface. So earlier today I created a file that contains a few instructions in Python. You can basically see them. They are just printing the same message. And if you want to open it with idle, you can, at least in Windows, edit it with idle. That will open the Python editor. In addition to that, if you want to run that program, you can run the module which will start the Python shell and run that program. Most programs that we write contain, in most cases, a few errors, and we would like to debug these programs. So you can do it easily in idle by setting a breakpoint at any line in your code and then opening the debugger window. By default, you do not have checked the source. Basically, that is, when you debug, you would like to see in the source code step by step as you execute the program. And at this point, if we run the module, it will basically start running the program, and you can step over through the program. Over will basically run every single statement one by one, and you can see in the original code where you are at every point, and you can see also the output that you get in the Python shell. So let's execute this program to completion, and now we basically ran our first program in Python with just the default idle interface. Most beginners start with idle, but soon afterwards they migrate to PyCharm or other Python editors. For the beginning, and not to request any more installations, but the basic Python installation, I would advise you to use the basic idle. Has everything that we need for this class. You can edit your programs automatically. It will indent with 4 spaces, which is the default for indentation of a block in Python. And you can also debug it, as you can see in the debugger that we have on the right hand side. So let's have our lecture about Python, and from time to time we will stop to run experiments in the Python shell or in the Python test file that we have. Again, just to remember, if you want to put breakpoints within your program, you can just click rec and set the breakpoints, and then you will see the debugger basically stop at that line when you try to run Python. Okay, so let's start our lecture on Python. So Python was created in the 1990s by Guido van Rossum in the Netherlands, and it can be downloaded at python.org. That is the main entrance point for Python. Many of you install Python through other sources, either through app install in Linux or in any version of Linux, or you install Anaconda, or you install PyCharm, and they all come with Python. But if you want the basic Python shell that you can actually run, you can install from the Python website. Also, there are two standard versions of Python, Python 2.x or Python 2.7x, and Python 3. Any version, x again. So Python 3 is not backward compatible with Python 2. Therefore, there are currently two branches of the Python shell. We are going to use in this class Python 3. I personally have on my computer 3.6, which I advise every student in the class to install. 3.6.4 is the latest version of Python this year, this semester. So Python 3.x is the newer version, but it's not backward compatible with Python 2.7. Therefore, it means that if you write a program in Python 2, it may not work in Python 3. Mostly, the issues are about the print statement. Python 3.x is more restrictive about putting parentheses around the arguments that you want to print in a print statement. We will use Python 3.x for all homeworks in this class. If you basically submit any homework, we will run it with the automatic grading script with Python 3. So make sure that your homework assignments submissions basically run with Python 3. Python 3 is the official version of this class and is not the default that you would get, for instance, in Ubuntu. In Ubuntu, by default, when you run Python, you actually run Python 2.7.4 or another version of Python 2. I personally request that you install Python 3, and you can install easily with sudo apt-get Python 3. And then you can basically run any program with Python 3. You should also probably install pip. Pip is the default installer for Python. If you need Django or any other Python packages like 6, you basically need to install them with pip install and the package that you need to install. So how do you start Python? You can start it with Python, and basically you will get into the Python interpreter. Or you should start Python 3 on some platforms. On Windows, Python is connected to Python 3, but on some instances, on some operating systems, you have to run explicitly Python 3. So remember, all the homeworks in this class are with Python 3. Also, you can use the default graphical user interface GUI that comes with Python, which is called idle. It comes from a Monty Python character, actually actor. It also stands for Integrated Development Environment. It's basically a command line interface in which you can write directly statements like print welcome to Python, or basically you can use both single quotes and double quotes for strings in Python. It also comes with an editor for files that you saw earlier. We have all of the three open basically in the earlier during this lecture, basically the shell or the command line interface. You can also run the command line interface separately with CMD. Again, it basically opens the same shell, the same output that you see in the command line interface, you will see in the idle shell. There are many other IDEs that some prefer for Python. As a beginner, I really advise that you start with idle. It's very simple, it's not cluttered by a lot of packages, and everything that you need to install, you can install separately. So we start with a simple program in Python. So in this program, what we can see is that basically the hash sign stands for comments in Python. We are saying that we are basically writing in the file that we display two messages, and this simple program in Python prints two strings. The first string is welcome to Python, Python is fun. It's very simple to the program that I wrote as a sample earlier in this lecture. It basically prints welcome to Python, and Python is fun. Remember again that hash stands for any comments in Python. You can also include comments with simple strings. You will see that basically if you start a method with a string, and that string can be over multiple lines of code, which can be done by basically using three single quotes instead of a single quote, and then you can span over multiple lines your comment. You can basically comment your code. That is also used by the Python documentation, and it will be collected for basically parsing later this semester when we are going to use Lex and Yak for parsing, for implementing parser generators. If you have a file, like the previous file, welcome.py, if you want to run it in the Python shell, you can basically just run Python and the file name. And then it will run, like in the previous example, it will print, in this case, welcome to Python, and Python is fun. At any point during the lecture, feel free to write questions in the chat, and either I, other students, or the TAs, which I see a few that logged into Stony Brook Connect, will respond to these questions. From time to time, I will take basically short breaks to see if there are any questions that are unanswered at this point in the chat. Thank you. So, how do we define variables in Python? Python is a dynamically typed language. That basically means that you do not declare the types of variables. So you can just assign the value that you want to assign to that specific variable. In this case, I'm assigning to a variable radius 20. Radius is now 20. You can actually print the radius, you can actually use the radius directly in the Python interface, and it will basically be 20. You can compute other values based on expressions, based on the variables that you already defined. Like for instance, area is a new variable, assigning the radius square multiplied with an approximation of pi. And then we use a print statement to print the area of the circle with a given radius is the area as a string. One issue in Python, as I said, is a dynamically typed language. However, it's a strongly typed language. Strongly typed language means that in Python, you cannot by default concatenate a string with a number. So in order to transform the number radius and the number area to strings, you need to cast them to strings. So let's actually try these examples in Python. So as we basically have it earlier, we can define radius as being 20. Because we have the debugger started, we'll basically have to quit the debugger. And again, let's run the radius. It's 20. From this point on, you can actually either print the radius, or you can actually just use the radius, and it will actually print still 20. As in the previous example, we can actually define new variables without having to declare them like we were doing in Java or other languages. In this case, the area is the radius square, multiply with the value of pi. And we are going to use, in this case, just 3.1459. Oh, I had a typo. The area is the radius. Multiply with radius, multiply with 3.1459. So from this point on, the area is 1256.636. As I told you earlier, if you have a string, like for instance, area equal plus area, will not work. Why? Because in Python, you cannot concatenate strings with numbers by basically just using the plus operator between a string and a number. You have to cast every single number to a string before you do that concatenation. So you can write, for instance, the area is equal with concatenated with the string cast of area. This is a feature of a strongly typed language. So we will see later this semester that we will classify typing into basically weakly typed languages and strongly typed languages. Java is weaker typed than Python. Another classification of data types in programming languages are dynamically typed languages and statically typed languages. We'll basically, in Java, you basically specify the type of any variable, of any location of memory, so you basically know how much space to allocate to that variable. In Python, you basically get types inferred by default by a process named called type inference. Java is also now evolving towards the same idea, and since Java 10, which was released in March this year, 2018, I think on March 10th, you can actually have local variables automatically inferred. The type of local variables can be automatically inferred. But Python had this for a very long time. And actually, in fact, before Python, SML, that we'll also discuss today, had it for a very long time. So, if we want to print the area for the given circle, we can actually print it with the print statement as we had before. So let's continue. What about reading inputs from the console? You can do it with the function input. So for instance, you can prompt the user to enter a string, and the user will basically enter that specific string, and you can read it into a variable by just assigning the value of the input function to the variable. If you want to evaluate a mathematical expression like 51 plus 54 multiplied with 3 plus 2, you basically can call the function eval. There are two functions in Python that we will learn later this semester. One is called eval, the other one is called representation, or RPR. Basically, these two functions are used for evaluating strings that may represent either numbers or they may represent either expressions, like the one that we have there. So let's actually test them in Python, both of these examples. So again, we are going to go to the Python shell. First, we are going to define some variable. Let's call it variable is equal with input. And we prompt the user to enter a variable. You can use either single quotes or double quotes in Python. Strings are basically both. Internally, it doesn't really matter how they are represented. When you print a string, you will see it within single quotes. If the string contains double quotes or single quotes, then it will be actually enclosed within double quotes. But basically, the internal representation of the string is actually the same. And as I said earlier, if you actually want to see what the string is internally, you can actually just use the RPR function for the representation, or the eval function. Okay. If you want to basically print multiple outputs, like for instance, the area is the given area, without having to convert the area to a string for the given radius and so on, you can basically just use multiple parameters. The print method takes as many arguments as necessary without having to manually convert every single output to a string and use concatenation. If you want to use the variable later, you can just use it. You can assign it to that variable another value. So in our example, we had the previous radius. So at that moment, the radius was 20. If we want to change the radius, we can just assign a different value to the radius. Let's assign 2, and we can compute another area. So before, the area was 1256. Now we can actually assign the radius square, multiply with pi, and the area has a different value. So basically, these are variables. They can be assigned as many times as possible. You don't need to declare them. You cannot declare them like you do in Java. So you can actually use the same variable name as many times as you can. And the same rules that apply in Java, a variable is available within the block that it was defined. If you actually define a method, which we will do a little bit later today, the variables that you declare in those methods are local to those methods. If you want to use a global variable, you actually have to define it as global. You can define global radius, global area, and then you are using the global variables. Unless you do that, the local variables are local to the method. Now, if you compute expressions, you basically will compute those expressions and you can assign it to variables. By default, when you divide even integers in Python, you will actually get a real division. So the most important fact that we haven't covered yet on this slide is that when you assign, for instance, to x, 5 multiplied with 3 divided by 2, plus 3 multiplied with 2, this is real division. So 3 divided by 2 is 1.5. That gets multiplied with 5. We get 7.5 plus 6 is 13.5. So real division is with 1 forward slash or 1 slash, and integer division is with double slash. So the difference between Java, for instance, and Python is that in Python we have two different operators for division. Integer division is with double forward slash, real division is with single forward slash. So again, we are going to do a single experiment, a simpler experiment. 3 divided by 2 is 1.5, and 3 quotient 2, basically integer division with 2, is 1. We basically get the quotient of the division of 3 with 2. Overflow. When a variable is assigned a value that is too large in size to be stored, it causes some overflow. For example, if you try to compute a very huge power, like 245 to the power 1 million, you will get eventually an overflow. Python will try, basically it has this numeric type that will actually store the biggest number that can be represented in your main memory. So it will take a very long time, in fact, to get this error, the overflow result, because what it will try is it will try to compute that value. It will basically continue basically computing that value until it gets a very, very large number. So Adam asked if the operator for power is star star. The answer to that is yes. 2 to the power 5 is 32. So star star is the operator for power. Thank you, Adam, for the question. Type conversion and rounding. So there is a difference between Python 2 and Python 3 for type conversion and rounding. And you will see it down when we talk about rounding of 4.5. Python 3 rounds 4.5 into 4. Basically, it's the if two integers are equally close to the number that we are trying to round, the even one is selected. That is, in fact, the IEEE standard. It's basically a standard that was adopted in basically early 2000s, that when you try to round a number that is equally far, is basically a 0.5, equally far from two integers, always we select the even one. So round of 4.5 will be 4, round of 5.5 would be 6 in Python 3. Python 2, on the other hand, always rounds to the higher number that is equally close. So you will see differences between this method in Python 2 and Python 3. But basically that is a problem that we basically need to take care of. But this slide is not only about rounding, it's also about type conversions. So earlier we saw that if we want to convert a number to a string, we have to do it explicitly with str and then basically passing in the number. And it will convert it to a string. Python is strongly typed, so we basically have to do this when we need to work with strings instead of numbers. If you want to do casting by truncating, basically a real to an integer, you can use the int data type, and int is basically converting it to an integer. Similarly, if you want to convert an integer to a real, you would use float. Rounding is a method for rounding. It finds the closest integer to that number, and it rounds the current number to that integer. And as I said, there is a difference between Python 3 and Python 2 about rounding. Please be careful about it. Maximum is also a function that it's available from the math module. Maximum basically computes the maximum number, is overloaded. If you call it with integers, it's with any number of arguments, it will return the maximum integer. If you call it with real numbers, it will return the maximum real number. Minimum is similar, basically it returns the minimum number, and rounding we already discussed earlier. Rounding finds the closest nearest integer, and if it's equally close to two integers, it chooses the even one. Absolute value returns the absolute value, ABS, of a negative number will be the positive minus that negative number is a positive number. Power is the same with using the double star operator that Adam mentioned earlier. It's also a method that is available from the math module. So power 2 to the power 3 is 8. If you need to import any kind of math functions, you can import only those functions from the math module, or you can import the entire math module with import math. So all of the examples that we had up to now, basically you can import math, and now you basically have access to all of the functions that you have here. So if you want to find the absolute value of an argument, you can use ABS or FABS, and then you will get the floating, basically the floating point number of that absolute value. Let's say I want to find the absolute value of minus 34.45, and let's try. It's just ABS. FABS, I think it was an earlier function which got renamed. It's fine. I will correct this slide later today. Please just remember that. Ceiling returns the basically rounds to the nearest integer greater than or equal with x. Floor rounds down to the nearest integer less than or equal with x, and returns that integer. Exponent returns the exponent function e to the power x. Logarithm returns the natural logarithm of x. So for instance, logarithm of e is 1.0. Logarithm of x in any base can be computed. Like for instance, logarithm of 10 in base 10 is 1, because 10 to the power 1 is equal with 10. Square root computes the square root of x. Sinus, cosinus, asinus, acosinus, tangenta. F mod returns the remainder of a division. Basically, you can divide two integers, get the remainder with F mod or with mod. And degrees converts angles from radians to degrees. So for instance, degrees of pi will return 3.14. It's basically a conversion function from degrees to radians, because the input for the sinus, cosinus, asinus, and acosinus is the angles in radians. Similarly to other libraries in other programming languages, like in Java, math.sinus, cosinus, asinus, acosinus also take the input as radians. Okay, more interestingly, the reason why Python is so popular today is all kinds of string manipulations can be done easily. A string can be defined as any sequence of characters enclosed within single quotes or double quotes. Python does not have a data type for characters, so if you want to represent a single character, you can represent it as just a string that contains a single character. You can assign basically strings to any variable, and you can use them from basically that moment as a string variable. Now, there are a few functions that are available for strings. First, if your string is a single character, then you can get the Unicode for that character, the Unicode encoding for that character. This only works for one single character. So for instance, let's do a different example. If we have a character C that is assigned the uppercase letter A, and we want the Unicode for that letter, we can basically ask, give me the ord of the character C. And it will give me 65. That's the Unicode of the uppercase letter A. But this really requires that your string contains a single character. If you have any more than a single character, like AB, the OR function will not work. It basically gives us an error that it's expecting a string of a single character. So you basically have to iterate through the string to get the character Unicode. A similar function can be applied for the reverse conversion. If you want the character for, let's say, in our case, 65, you will get the uppercase A, and you can assign it to any variable of the type character. The string function can also be used to convert any numbers into strings. So if you have a float or if you have an integer, you can convert it with a str function, as we did with the radius and the area earlier today. String concatenation can be done with a plus operator, and the plus operator is basically just overloaded for strings because it also works for any kind of numbers. Plus can basically compute the sum, or it can do the concatenation. Again, numbers and strings are not compatible in Python, so if you want to basically concatenate a string and a number, you need to convert the number to a string. So you cannot convert by default integer objects into strings implicitly. You basically need to do it explicitly with the str function. In Python, all data, including numbers and strings, are actually objects. An object is an entity, and each object has an ID. You can basically get the hash number for that object and a type. The objects of the same kind have the same type. You can get both the ID and the type with the functions ID and type. So let's see some examples. Basically, if you have n is a variable that is assigned an integer 3, you can get the ID of that variable n, and you can get the type. In this case, it actually prints the class of that specific type is the type integer. Similarly, if you have a float number or if you have a string, you can get the ID and the type of those specific strings and float numbers. The ID is always unique, so if you have different objects, you will basically get different IDs. One thing that you may have to be aware of is that if you are using strings, like for instance welcome, and you assign the same string twice to two different variables, the ID of those variables is the same. Why? Because it's the same issue that you have in Java. These are interned strings. These are strings that are created only once uniquely in memory, so they have the same ID. So let's experiment a few of these functions. Again, we are opening the Python shell. So as in the example, we assign to a number 3. We can get the ID of that number and the type of that number. And it prints the type integer. Similarly, if f is a float number like 3.15 or 14, we can get the ID of that, and we can get the type of that. Now, we will assign to two variables s1, welcome, and s2, the same string. And if you ask for the ID of s1 and the ID of s2, they should be the same. If you assign, let's say, to s3, the same string, welcome, and you can use single quotes, double quotes, intermixed. The ID of S3 is the same as before. So you can see that basically these are internal strings. They are created only once in memory for you. The type of all of these objects that we created as 1, 2, and 3 is basically the type string. Let's stop for a second and see if there are any questions in the chat. Any questions up to now before we continue with more complex functions for strings? We continue to learn objects and so on. So one question from Adam that I can see in the chat is that if you change the value of S1, you basically have a different object. So S1 is now, let's say that S1 is hello. Now we have a new reference to a different object. If you are asking for the ID of S1, it's a different ID than before. You can see in the last, previous to last bit is 88 instead of 28. Yes, you are right. S2 and S3 are different. So S2 and S3 are still welcome. They are still the same ID. We just have a new reference S1 that points to a different object that is hello. Okay, excellent. So if we have no more questions, thank you. We continue. If you want to obtain a new string that is the original string S in lowercase, you can invoke the methods lower and upper for the string S. So again, let's do the same experiment. S was welcome, and now we have S1 is S.lower. S1 is welcome in lowercase. If S2 is assigned S.upper, S2 is welcome in uppercase. If we want to format any kind of numbers with format extensions, basically if we want, let's say, a float number with only 2 digits after the decimal point, but printed on 10 characters aligned to the right-hand side. So we can use format of the number that we need to format, and then the format specifiers are similar to the ones that you remember from Java. Basically, you specify first in this template the number of total characters that you want to have in that specific string, the 2 digits after the decimal point, and the type that we are printing. F means any kind of floating point number. There are other notations as for string, and again you can specify the length of that string and so on. And it will align to the right hand side that specific field. So 10 is the width of the field, 2 is the precision, occurs after the decimal dot, F is the conversion code, and the entire thing is a format specifier. So in our case, if we wanted to print in the first row 57.46, we basically, it also rounds it to 57.47 and precede it with spaces. The question mark stands for spaces. And all of the other examples follow the same conventions. Python 3 by default uses 4 spaces for blocks. So if we want to define blocks, we should use 4 spaces. Again, for historical reasons, because Python 2 and previous versions of Python were using tabs, tabs are accepted for already indented code, with the condition that we should not mix the use of tabs and the use of spaces for indentation. There was a question earlier this week on Piazza, how did I set up my Notepad++? You can do it easily by going to the View menu, and you basically will see with dots any kind of spaces, and with arrows any kind of tabs. So it's very useful, and I personally set up my editors in such a way that I see exactly what kind of white spaces are used in any point in the editor. So again, Python 3 default requirement, which you can actually find online at this link, which is one of the Python implementation requirements, is the PEP requires that the indentation of methods of if statements is with 4 spaces, and it's not using any kind of open curly brace, close curly brace for blocks. Why are we talking about this? Because any kind of conditional statements like if statements, while statements, methods must be done with indentation. Again, when you write in any kind of editor that is not by default set up for Python, you should make sure that you are using indentation of 4 spaces. So we talked about that because next topic is conditional statements. So we have the first conditional statement is if the radius is greater than or equal with 0, you can enclose it or not within the parentheses. Colon stands for basically the beginning of the if statement. Then we compute the area. The area is the radius squared multiplied with pi. And then we print the area of the given circle. Else we print negative input. Again, the else is not required. If we continue with other code afterwards, that is fine. We basically just write a single, not a two-way if statement. So let's go back to our Python interpreter. Let's write an if statement. We had the variable radius before, which is 2. So now we write an if statement if the radius is positive. Then the area is computed. And is printed. Otherwise, we print negative radius. So in this case, pi is not defined. Okay, I forgot to put math of pi in front of it. Let's write it again, but this time using a constant 3.1445. So radius, if it's positive, we compute the area. We print the area. Else we print negative radius. So we see that the if statement got executed on the spot, and it basically returned the area of a circle with radius of 2. So don't forget to put a colon after every if definition, use indentation of 4 spaces. The code that you will find in the lecture notes uses exactly that type of indentation, so you can just copy it and use it in your program. If you are using the value of pi, as I did in the previous example, you should import it from the math package. If you have multiple alternative if statements, so let's assume that we have a cascade of if statements. If the score is greater than 90, then we assign to the grade the value A, a string A. Else, if the score is greater than 80, then we assign to the grade the value B. Else, if the score is greater than 70, we assign to the grade the value C. Else, if the score is greater than 60, we assign to the grade the value D. Else, we assign the grade F. You see that a lot of spaces are accumulated because of indentation. Python uses indentation of 4 spaces for every block. So for instance, by the time we get to, let's say, the last possible case, we already have an indentation of 16 or 20 spaces in front of it. So we need a lot of indentation, therefore Python actually provides us with an alternative else, which is the else if or elif So in this case, basically, the else contains another if, so it's basically integrated as part of the if statement. So let's do a similar example. Let's say that we want if the radius is greater than 10, we would print, let's say, greater than 10, else, or elif. Let's say that the radius, if it's greater than 0, then we print positive. Else, we print negative. And in this case, it's actually 2, so it actually goes on the second branch and it's true, so therefore it prints positive. The radius was 2 before, so we actually got exactly where we expected. Okay, great. What about loops? So the first type of loop, the most important one, in fact, because everything else, it's actually a rewrite of this loop. For instance, the for loops are just rewrite of while loops, in fact. The first type of loop is the while loop. So for a while loop, you always need some kind of a loop control variable that is initialized at the beginning of your code, while that variable is less than some end value. We have a loop body followed by an increment of the variable. So in this case, let's assume that, similar to the previous example, we want to write a while loop. While first we need a variable, so let's define I is equal with 0, and then while I is less than 10, we would print the value of I followed by an increment of I. So we can see basically what happened. It printed exactly what we expected. I'm not exactly sure why I++ cannot occur as a post increment. No. Okay, there is an issue in the slides. Let's modify it. For those of you that actually take it directly from the slides, I will use pre-increment. I'm not sure why post increment does not run in Python, but we can actually, I will test it after the class today. Okay, for loops. For loops are using a function called range, where you specify the initial value, the end value, and optionally the step. So an example of a for loop would be, for every I in the range from 4 to 8, not including 8, print the value of I. If you want, you can also specify the step. So for instance, if you want from 4 to 8 with a step of 2, you can add a third parameter to the range function. So let's do that as an experiment. For every I in the range from 4 to 8 with a step of 2, print the value of I. We'll basically print 4 and 6, because 8 is actually the upper range and is not included in the print statement. If you only give an integer that is a positive number, then it will start from 0. So for every I in the range up to 4, not including 4, print the value of I. We'll print 0, 1, 2, 3. Again, if you have a range that basically is with a step, you can basically start from the initial value to the end value not included with the step that is given. So let's do one more experiment in Python. For every I in range of 10, that will print the numbers from 0 to 9, we will print I. So we will print from 0 to 9, and now we have experiments with all of the different versions of range. Range by itself is actually not evaluated. Python uses another programming language technique that we learned this semester called basically lazy evaluation, which basically means that range is not evaluated until you actually need it. In fact, you can actually see that if you run range directly in the command line, it will tell you that range is actually range from 0 to 4. It's actually a type in Python. So it will not evaluate range from 0 to 4 until you need it. If you need it, like in a for statement, then it will evaluate it. Otherwise, it does not create a list or anything else. Functions. So as in any programming language, we have function abstraction. We define a name, and that name stands for a sequence of statements that get executed when we call that parameterized function with actual arguments. So for instance, if we want to write a function, this function is called sum from I1 to I2. We can basically document that function using a docstring. The docstring is the first string that is detected in the function. If the string is spanned only over one line, you can use single quotes. If you are spanning over multiple lines of code, you should use 3 quotes, and then you can have a long documentation. In this case, this function defines a variable result, and for every I in the range from I1 to I2, the result is incremented with the value of I. Finally, we return the result. In the main method, this is a common definition in Python. You don't always include the main call, but you do want to have a main method for your program. In the main method, we print multiple sums. The sums of the numbers from 1 to 10, from 20 to 37, from 35 to 49, and they are all computed by invoking the function sum for those specific values. So let's again do this experiment. We are going to edit it with idle. I prefer when we define functions that we are actually writing them in a file. So in this case, we go back to our test file and we are writing this program. So we define the function sum, and this sum takes 2 parameters, I1 and I2 as parameters. Again, we use colon for basically defining the indentation, the block. We can document this function. This is a function that sums. Again, if you want to span over multiple lines, you should use 3 quotes, and then you can span over as many lines as you like. So let's actually add more stuff in here. This is another line. So that is called the Python doc, or the documentation for this function. Let's implement the function. The result is initially 0. And then for every I in the range from I1 to I2, not including I2, we increment the result with I. And finally, we return the result. We define the main function, which is common in Python. You always define such a main function, and you print the result. In our case, we print the sum of the numbers. Let's just print them directly. The sum of the numbers from 1 to 10. And maybe other tests, like the sum of the numbers from 20 to 37. Finally, we invoke the main method, and we can comment it out we invoke the main method. So at this point, I'm going to run this module, which basically computes the two sums that we had before. This is how we define functions in Python. We use indentation for blocks, and in most cases, we define a main method and then we invoke it. Excellent. Again, feel free to put any questions that you may have into the chat. I'm reading it on a separate computer, so I can basically see it from time to time. Okay, how do we define classes? So we can define classes by basically defining class. Class, in this case, circle is a new class. The initializer, the default constructor, is defined with underscore underscore init underscore underscore. These kind of methods that are called dynamic methods or non-static methods in other languages, methods that are for the object itself, always take the self object. Self is similar to this in Java. They take the self object as a parameter. So init takes self and the optional parameter radius, which if it's not specified, we get a default value of 1 for the radius, and assigns to the data field radius of the current object the value radius. At this point, if we want to get the perimeter of the current object, like for instance the perimeter of this circle, we would be able to use another method. We define the getPerimeter method that returns 2 multiplied with self.radius multiplied with math.pi. This is in case that we imported math. Similarly, getArea for the same object returns radius multiplied with radius multiplied with pi. All of the for the self object, for the current object. If we want to write a modifier, we would set the radius, again for the self object, to the new given radius. The string method and the representation method are common methods to be implemented in every class, and in this case, string returns a string representation of that class. Basically returns that this is a circle of the given radius, and the radius is the radius that was basically declared. So let's actually try this in Python. Again, I'm going to define it into a file. I'm going to use the same file as before. So I'm going to import math. I'm going to declare the class circle. If you have a superclass, you can define it within parentheses. Basically, after you've defined the class, we are going to see it for another class later today. Then you can define your constructors. So for instance, the init constructor takes self, the current object, and the radius. Let's use the default value of 1. And then self.radius, which is similar to this dot radius in Java, is assigned radius. We can define the method getPerimeter. Also for self, always we need to do this in Python. We return 2 multiplied with radius, self.radius multiplied with math.pi. And let's also define the string method. That's very important. For every class, you should have a representation function or a string method. Most of the cases you have the other representation function, but that's fine. So the string method in our case returns the type of this class with the radius. And we need to convert the radius to a string. So let's define our main method in the same class. So in our case, the main method basically contains, like in our previous example, a print statement to create a circle. So C1 is a new circle. We can specify a different circle. Let's say C2 is a circle with radius, different radius of 2 maybe, and then we have a print of C1 and print of C2. We invoke main and we run this module. Okay. Oh, self.radius, we had a small typo. Okay, let's run it again, and everything will run fine this time. So you see, we created two circles. One is of radius of 1, the second one is of radius of 2, and they are both printed in the Python shell. Okay, so like we did it in the previous example, if you have circle in circle.py, you can import that class circle from circle.py, and then you can, in the main method, you can create several circles, you can print their areas, you can print their perimeters and so on. Okay. How do we implement inheritance? So let's assume that we have in a different file, geometric object, some kind of superclass geometric object. If we want to define that circle is a subclass of that geometric object, we can basically just define a class circle and then within parentheses the superclass, like geometric object. If we want to call the super constructor for that specific class, we'll basically call super.init, which will call the super constructor. In this example, I renamed the radius to underscore underscore radius, and it implements exactly the same program that we saw before. It basically implements the class circle. We will see a different example later this semester when we write our first parser. Basically, a parser parses any program into what is called a parse tree. A parse tree contains nodes. So we will define a class node that has multiple types of subclasses, like for instance, expression node, block node, and so on. So the superclass in that case, it will be the class node. It will have by default several methods for executing statements or for evaluating expressions. And then we will implement subclasses of those nodes, like for instance, expression or binary operator, and so on. And let's actually do just a simple sample to give you an idea how we will implement parse trees, and that will make it very clear for most of you, basically, how to write abstract syntax trees in Python. So, as I proposed, basically, we will define a class node. By default, the class node will contain the constructors. There is nothing to do in the class node. In fact, also a thing that many people prefer is to actually pass the implementation of the superclass if that superclass is just a placeholder. And then you can implement subclasses like, let's say, binary operator node. It's a subclass of node. And then we can define our constructors. So in the case of binary operator, the constructor takes as parameters the self, let's say the operation and the operators O1 and O2. And then internally, basically, we have to initialize the operators. So self.operator is the operator formal parameter, self.operator 1, operand 1 is operand 1, and self.operand 2 is operand 2. So at this point we can implement, let's say, an evaluate method. Again, it takes self as a parameter, and let's say that we want to evaluate that specific expression. So depending on the type of the expression, if let's say the operator is plus, we would basically evaluate operator 1 plus operator 2. And let's say that we have many other cases, minus, multiplication, and so on. By default, we just return a value. If nothing else is reached, we return 0. Similarly to this, we can define a statement class, like for instance, the class print node. And the class print node is also a subclass of node and has similar methods, like for instance, the print node takes an expression to be printed and initializes self.expression to the expression passed as a formal parameter. And then when we execute that specific print node, we basically evaluate the expression. So a print node will use a print in Python that calls self.expression.evaluate. Okay. So in our main method, we would probably create a print node that contains a binary node as internal parameter. So for instance, print of a new print node, and normally I should have defined the class with uppercase of a new print node of, in this case, I'm going to create a new binary operator node that contains plus between 1 and 2, and that will be evaluated internally in the print node, and here we execute that specific print node. So basically it will create this tree that contains a print node with a child that has an expression that is a binary operator node, and then we are calling the method execute on this new node, which will call the method evaluate on the binary operator node. I'm pretty sure that this basically exemplifies pretty well the parse tree. Okay. So how do we add fields to objects dynamically? Let's assume that we create an employee class, we pass the implementation, that means that we will implement it later, and then we create an empty employee object like John, and we can add dynamically fields to John. So John.name is John Doe, John.department is computer lab, John.salary is 1000, and so on. So you don't need to implement, like in Java, classes with exact set of fields. You can actually dynamically add fields to classes as you actually use them. This is different than Java, because Java is statically typed. Everything has to have a type before we can run it in the JVM. In Python, because it's an interpreter, we can actually add fields by simply by adding them at runtime to any object. Exceptions. So that's mostly all about classes. Now, if we want to raise exceptions in Python, we can do it with raise instead of throw, as it's done in Java. So in this case, we raise a runtime exception or runtime error negative radius. This will be caught by a try-catch statement, and we can catch the exception as some variable name like e, and then print that specific e to see what was the exception that we basically got. Okay, so let's see examples of classes. The string class is probably the most important class in any programming language. We can create a string either by specifying a new string using intern strings in Python, or we can use the constructor for string. str is the class string. str of empty will create an empty string. str of welcome will create a new string for the string welcome. Since it's very common that strings are basically created on the fly with double quotes or single quotes, you can actually define them, and Python takes them as strings, objects. Strings are immutable. Once a string is created, like in Java, its content cannot be changed. To optimize the performance, Python uses one object for strings with the same content. So if you assign to the same to different variables s1 and s2 the same string, like welcome and welcome, you will basically get s1 and s2 are the same object, basically references to the same object. Similar to Java, you can get the length of a string with the function len. You can get the maximum character in the string with the function max, and the minimum character in the string in Unicode order with the function min. And as we know, the indices of the uppercase letters are lower than not the indices, the Unicode encodings for uppercase letters are in the Unicode encoding before the lowercase letters. So in our case, the minimum letter in the string is actually the letter W. So let's actually do a few experiments. We are going to have a lot of such experiments in Python today. So we can define a string. S is, again, welcome. Let's say that S2 is a new string for welcome. The ID of S and the ID of S2 are the same, even if they were created with str. Now the length of S is the same with the length of S2. They are basically the same object internally, and they are the number of letters in those strings. The maximum of S is O. The minimum of S is W, because uppercase letters are before lowercase letters. The plus, multiply, and index operators are basically overloaded for strings on top of the sums that or products that we have in for numbers. So if we want to concatenate two strings, we will get a new string that is the concatenation of the two strings that we already did today. If you want to duplicate a certain string as many times as you want, you can use the multiplication operator. So you can specify, I want to duplicate the string s1 2 times in the string s4. That will duplicate the string 2 times. In our example, let's do it 4 times. So what is 4 multiplied with s? It will be welcome, 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 welcome 4 times. If you want to extract a slice out of the string, so for instance, from S, I want to extract the slice from index 1 to index 4, you can use the colon notation. It basically extracts the slice from index, the lower index up to the upper index, not including the upper index. So we can actually see that the character for index 6 is not included. So for instance, in the previous example, if we want to extract only one character, like from 1 to 2, that will return only E in welcome. So the character at the upper index is not included. If you want to find if a substring is inside a string, like for instance, does welcome contain E, we can actually just use the in operator. The in is basically membership, and it works for membership in arrays or membership in strings of substrings, and it works on any length substrings. So for instance, is EL in the string S should also return. It returns false. Okay, let's try again. It should have worked. Yes, it works. I'm not sure why with double quotes doesn't work, because it should work. Strings are represented in the same way in Python. Anyway, Python also uses negative indices. -1 stands for last character in the string, and then we have negative indices before that last character. So if, for instance, we want the string from the beginning to the last index, you can actually specify it with negative indices. S of -1 is the last character, S of minus length of the string S is the first character. And you can extract also slices using negative indices. Here we have an example that is exactly the one that I tried in the command line. It seems that for some reason in Python you have to use single quotes, not double quotes. So let's try one more time. And now it works. I'm not sure why double quote EL did not work before, but anyway. Not in basically is the negation of in, and it basically returns the inverse. So if come is in welcome, then not in returns false. It reverses, is the negation of come in as. If you want to loop over every character, you can actually write it with an for loop for every character in the string, print the character, or for every index I in the range from 0 to the length of the string, you can actually print every index, like s of I, with an index variable. If you want to compare strings, in Python you can compare strings with the double equal operator. And the double equal operator does lexicographical order, so basically you can compare two strings with just double equal. It compares the content of the two strings. If you want to check that the strings are not the same, you can use not equal. Not equal is represented the same as in Java, exclamation sign for negation, like in logic, equal. You can also compare strings with greater than, equal, less than, and less than equal operators. This will do lexicographical order. So let's take a look at our example. G is the same, the first character is the same in the S1 and S2. So then it will compare R and L. R is greater than L, therefore S1 is greater than S2. So you can use basically comparison directly if you want to compare strings in lexicographical order for sorting them. There are many other methods available in Python, the string class. You can check if a string is alphanumerical. It returns true if all the characters in the string are alphanumerical and it has at least one character. It will return false if the string is empty. If alpha, returns true if all the characters in the string are alphabetical, so it doesn't contain numbers, but they are all alphabetical, no special characters, and if there exists at least one character. So again, it will return false for empty strings. IsDigit returns true if the string contains only number characters. IsIdentifier returns true if the string is a Python identifier, which is basically the same with other languages. It's an identifier is an alphanumerical string that contains basically that starts with a letter and may contain underscore, but that's the only special character that we may have. So identifiers are, for instance, D2, Paul, and so on. They are all strings that start with a letter, contain letters and digits and underscores. Is lower returns true if all the characters are in lowercase and there exists at least one character. Is upper returns true if all the characters are in the string are in uppercase and contains at least one character. And is space returns true if the string contains only white space characters. Ends with checks if the inner string SL, S1 is a suffix of the original string, starts with, returns true if the string starts with the prefix S1. Find returns the lowest index where S1 starts in the string, or -1 if it's not found in that string. rfind returns the highest index or the last occurrence of the substring S1 in the string, and counts the number of non-overlapping occurrences of the substring. So let's actually experiment some of them. So from the beginning, we had a couple of examples. Let's assume that S1 is green. S2 is glow. So S1 is greater than S2, returns true. S1 less than equal with S2, we return false. We had a couple of methods that we talked about. Let's say, does S1 starts with gr, returns true. Does it start with any other character like L? Does not. Find returns the index, so S1 dot find the first occurrence of E in green, it will return 2, and S1 dot rfind, which is the last occurrence of E, returns, oh, I misspelled it. And I misspelled twice, in fact. It's 3. And count the number of occurrences, S1.count the number of E's, returns 2. There are 2 E's in green. Okay, excellent. So let's continue. Capitalize returns the string in capitalized notation. Basically, the first character is uppercase for every word, with only the first character capitalized and the rest are lowercase. Lower returns the string, a copy of the string with all characters in lowercase. Upper returns a copy of the string with all characters in uppercase. Title returns a copy of the string with the first letter capitalized in each word. Swap case, swap is the case and returns a copy of the string. And replace, which is an important method, returns a new string which replaces every occurrence of the old string with a new string. So for instance, in our example, if we want to replace every E with an A, it will return GRAAN. Basically, it replaces every E with an A. Okay. Stripping white spaces. Strip basically strips the beginning and end white spaces. That includes new line characters, space or tabs. Every white space will be removed from the beginning and the end of the string. If you only want at the beginning or at the end, you can use lstrip and rstrip. Formatting, we saw the format method at the beginning for numbers. This is actually for formatting strings. You can central a string in a line by adding spaces before and after that specific string. So for the string, you can specify the width, and then it will return a new string which centers the original string within the new string on that number of the characters equal with the width. Similar with ljustify and rjustify, which adds spaces only on the left-hand side or on the right-hand side. If you want to build graphical user interfaces, you can import Thinker. There are a lot of libraries for graphical user interfaces. IDLE itself is implemented with Thinker, which is actually TCL/TK implemented in Python. So Thinker is one of the GUI libraries. Many people prefer other GUI libraries, like I developed applications with QL, which is a different GUI application, but Thinker is great. Basically, you can create a new window by just importing all the classes from Thinker package. You can create a new window with TK, and then you can put in that window labels. Like for the root window that you created, you can create a new label in that root window that contains welcome to Python. You can add a new button in that root window that says click me, and then you invoke pack, which basically displays the label for both. You invoke pack and button in that window, and you create an event loop to actually read events for clicking that specific click me. Okay, now there are I would later this semester I will post in fact a few examples of GUIs for simple programs, but most importantly for today is to have an overview of the entire Python. So before we continue with more advanced event programming and so on, we should actually learn how to create data structures with Python. And by data structures, I mean lists, which are the equivalent of arrays or dynamic lists in Java, and then dictionaries and sets and tuples, which are basic types that every programming language must have. So we are going to go over an introduction to lists, sets, dictionaries, which are basically maps or hash maps, and tuples. So we start with lists. Lists are collections of elements, and in Python you can have heterogeneous collections of elements, so you don't have a requirement that the list may contain only elements of the same type. So you can create a list using, again, the class list. Is one of the standard classes, and you can create the list by invoking the default constructor for list, or you can create a list out of a predefined list using the notation open close bracket. You can create a list of strings, of numbers. You can create a list out of a range. So in this case, basically, the list contains the elements of that range. Now you can see the difference that range is not actually a list. Range is actually a lazy evaluated function. List out of the characters of a string. So list of A, B, C, D is basically the list of the strings A, B, C, and D. For convenience, Python also lets us to create lists using the shortcut notation by using brackets. So we can create a list, the empty list, by just open close bracket, list that contains 2, 3, 4, list that contains strings red and green. So again, we are going to do a few examples. So my first list, L, is an empty list, or L is a list that contains 1 and the string A. So we have heterogeneous lists, basically 1 that is a number and A that is a string, or a list L that is formed out of the characters in the string A, B, C, D. And the list L now contains actually the strings A, B, C, and D. Also, a list can be constructed out of a range. So to the constructor for list, we give range of, let's say, 5. And that actually creates the list L that contains from 0 to 4 all the numbers. Okay. Now, what can we do with lists? The same thing that we did with strings. We can get from the list the element at index 1 or the element at index -1, which is basically the last element of the list. So the first thing that we can do with lists are indexed elements. Also, we can append lists using either plus or the append method. So basically we can do L.append another list, let's say 5 and 6. So now the list L basically has these new elements added at the end of the list. It actually, append does, it only adds one element in the list. Insert adds the element at any given index. Remove adds the element, removes the element and doesn't return anything. Index returns the index of the first index of an element in the list. Count counts the number of times that element appeared in the list. Sort sorts the list. Reverse reverses the list, and in place, these are all mutable methods. Extend is appends all the elements of the list to the original list. So let's say L extend the list with the elements 7 and 8. So now the list contains from 0 to 7 and 8. But that can be done identically with the plus operator. So the plus operator is basically overloads and probably is used more often than just extend. Pop removes the element at the given index and returns that element. The square brackets denotes the parameter is optional. The fact that pop by default works like a stack. It pops the last element of the list. So for instance, L.pop will basically return 8, and now the list is up to 7. So it basically doesn't contain the last element 8. So it was a mutable method. All of these are mutable methods. They basically modify the list. The indexes in the list start from 0. So L of 0 is the first element, and L of the length of the list returns -1, returns the last element. So there is also the length of the list method, which returns the number of elements in the list. Maximum, like in the case of string, returns the maximum element in the list. Minimum returns the minimum element in the list. Sum returns the sum of the elements in the list if all the elements are numbers. Random.shuffle list basically shuffles the elements in the list in a different permutation. Now, similarly with strings, we can extract either slices or we can concatenate lists with the plus operator. We just saw this. Or we can create a new list that contains multiple occurrences of the elements of the original list. So the multiplication basically duplicates the number of times that list occurs in the new list. So for instance, if we want to duplicate our list 4 times, it will basically duplicate the list 4 times. More importantly, we can actually modify the list and we can extract elements from the list. So for instance, if I want the elements from index 1 to index 3, I can use a range from index 1 to index 4, not including 4, and that will extract the elements in that range into a new list. This does not modify the original list. Any of these methods do not actually modify the original list. They return new lists as results. We also have negative indices, as we saw in the examples already. For instance, if we want 21, the last element of list 1, we can return list of -1, that returns 21. List of -3 is -1, -2, -3 is 2. If we want to check if an element is in a list, we can use the in operator the same way that we used it for strings. We can check if 2 is in the list, or we can check if real numbers are in the list. Let's do this example. So is 1 in the list L? And the answer is true. Yes, 1 is in the list L. Comparing lists. This is list comparison. So is not only the fact that these two sets are equal, but the fact that the element occur in the same order. So for instance, if we have two lists of colors, green, red, and blue, and the second list is red, blue, and green, it does lexicographical order. So it compares green with red, it compares red with blue, it compares blue with green. It stops at the first two that are not equal. So basically list 1 is different than list 2 because green is different than red. So if we're asking if they are equal, the answer is false. If they are asking if they are different, the answer is true. Same applies for lexicographical order. Is list 1 greater than list 2? Yes. No, it's false, because it should be false. Oh, list 2 greater than list 1? Yes, it's true, because the first element, which is red, is greater than green. Why? Because R is greater than G. So it does lexicographical order not only within the list, but also within the elements in that list. Okay. How can we split? We can split either using the default space as a delimiter by invoking split function on those basically on the spaces in the string, which returns a list of strings, or we can split on any other delimiter. And we can use regular expressions for delimiters. We can use a selection with square brackets, which is a disjunction of multiple characters. In this example, I'm using split on hash sign, which basically returns a list of the substring in that original string. Python passes values by value, passes arguments by values to methods, exactly like Java does. However, although in Python everything is in fact an object, numbers and lists or strings are passed differently. So what does that mean? Let's take an example. We define the method main, which initializes x with 1 and y with the list 1, 2, 3. We invoke the method m on the element x and y. Then we print x is the value of the string x, and we print y of 0 is the value of the string y of 0. We define the method m as taking the number, which is basically one single integer, and the numbers array, which is basically the array or the list y, and we initialize number to 1001 and numbers of 0 to 5555. Then we invoke the method main, which basically will print the value of x and y of 0. Similar to Java, this will actually not modify the value of x, but it will modify the value of y of 0. What happens is the fact that y and numbers are basically references to the same list in memory. So y of 0, when it's modified in numbers of 0, it will modify y of 0 to 5555, while number is just a clone, a copy of the original x. So number will be still the original 1 instead of 1001. So let's do this experiment. This is very important. Although some of you already know it from Java, I don't want to make any assumptions at this point. So we're going to come to our original program, which we will actually delete and rewrite from the beginning. First, we are going to define the function m. It's defined below in our example. So m takes a number and numbers. And all that it does, it assigns to number 1001 and numbers of 0, 5555. Then we define the method main, which assigns to a variable x the integer 1 and to a variable y the list 1, 2, 3. Then we invoke the method m on both the actual arguments x and y, actual parameters or arguments x and y. And then we print the values of x and we print the value of y of 0. The expected output is, as I explained earlier, 1 for x and 5555 for y of 0. So it's exactly what we expected, 1 and 5555. At this point, let's see if there are any questions in the chat. So any questions, please ask them in the chat, and then we'll continue with pass by value in Python. But as you can see, it's exactly the same with Java. Exactly the same meaning, the same way that we ran in Java. So every algorithm that you've wrote in Java, in your CSE114 class or Computer Science 1 class, is exactly similar in Python. So you can write binary search that takes a list and a key, initializes the low and the high range indices with 0 and the length -1. As long as the high is greater than equal with low, middle is the integer division of low plus high divided by 2. We compare the key with the element in the middle, list of middle. If the key is less than the list of middle, then we discard half of the array. The list is sorted, so we want to find the index in logarithmic time of the key in that list. So we can, since the key was less than the element in the middle, we can discard all the elements that are greater than the element in the middle. So the high is reassigned, the index for high is reassigned to middle -1. If the key is equal with the element in the middle, we return the index middle. Otherwise, we assign to low middle +1, because the only other option in this case is that the key is greater than the element in the middle. If we get to, if we exit the while statement, we actually know that high is lower than low, and the key was not found. So we return a negative index of where the key should have been in the list if it would have been there. Selection sort is very similar. We basically range from the beginning of the list to the end of the list, and for every index I, we find a minimum in the list from I to the length of the list -1 to the end of the list. By assigning to the variable current minimum the element at index I, and the current minimum index the index I, and then for every j in the range from I +1 to the length of the list, if the current minimum is greater than the element at index j, that means that the current minimum is not the minimum in the array, in the list. Therefore, the current minimum is assigned the element at index j. This becomes the new current minimum or the partial minimum up to that index j, and the index is equal with j. In the end, after we iterate over all the elements and we found the minimum from I +1 to the length of the list, we swap, if it's necessary, if the current minimum index is different than I, we swap the element I with the current minimum index. Finally, if we did this for every element, we found the minimum for every position up to the end of the array, we return the new list that will basically be the sorted list. Now, in order to basically be complete, if we want to read the file, we can do it easily by opening it in writing mode. This is standard ISO for every programming language to open files. And in Python, we can write to that file by using the file handler out file that we created with the open. So we can read any specific number of characters as a string from the file. If the argument is omitted, it reads the entire remaining content of the file. So you can read an entire file with read line, reads line by line the file, read lines, reads the lines into a list, writes a string to the file, and closes the file. However, before you read any input, you should you should basically check that that file exists. There are a lot of libraries that we are going to overview in a few minutes at the end of the lecture. os.path must be imported is one of them. How do we write and read from a file? Here is a sample. We open the file a.txt in write mode. We write de in that file. We close it. And then we open the same file in read mode. For every line in the file, we print that line, after which we close the file. Tuples. So as I said earlier, we are going to go over 4 different types of data structures in Python, the most useful ones. The first one was lists. The second one is tuples. Tuples are a little bit different than lists in the fact that you cannot modify them. Once you create them, You can't insert elements in the tuple at any location. In fact, it is a type that is most useful because of the fact that when you pass multiple arguments to a function, the function takes those arguments in a tuple. It's basically, you can consider that is a function defined on the Cartesian product of the domains of every argument in that tuple. So you can create an empty tuple by using parentheses instead of brackets, or you can create a tuple using the tuple class. So tuple basically will be invoked on the constructor. In this case, we are creating a tuple out of a list. And the list is created for every x in the range from 1 to 5. We return a double of x. What we actually just created here is something different. It's called list comprehension. It's a shorthand notation to write a for loop over a range to extract elements. It's like the set notations that you are using in mathematics. You say for every x in some set, you compute a value and that will be a value returned by the set. In fact, Python also has what is called set comprehensions, which are basically the same with list comprehensions, but the result is not a list but a set. So the order does not matter. You can also create a tuple out of a string by actually getting the list of characters in that tuple. Now there is a typo in this case. This is really a tuple, it's not a list. So we should use them as tuples. Okay, great. So tuples are different than lists in the fact that you cannot modify a tuple. When you return from a function, let's assume that you return, David asked a question this second, when do you use a tuple? In Java, when you return a value, you can only return a single value. Let's say that you want to implement a function in Python that computes both the minimum and the maximum of the elements in a list. You have to return a tuple of 2 elements. So you basically will return a tuple. Yes, you can also do it through lists, but the real meaning is that you are returning 2 elements at the same time. So I've never did it before, but we can actually try to do it real time. So let's define a function minmax. The function minmax takes a list L as parameter, and we want to compute the both the minimum and the maximum of that list. So first, let's define 2 variables. Minimum is L of 0, maximum is L of 0, and then we can write a for loop that actually checks the elements. So for every element E in L, if E is less than minimum, then it should be the new minimum. Minimum is E. Elif, if maximum is less than E, then maximum is equal with the element E. And finally, we return the tuple minimum and maximum. So let's actually use it. Let's say I want actually min and max to be computed from the min max function applied to the list, some random numbers. Okay. Okay. And let's see if it actually runs. Yep. So we loaded it, but we didn't print them. So let's also print them. Print min and print max. Let's load it again. And it printed the minimum is 1 and the maximum is 6. So one reason that you can use tuples is the fact that you can have multi-way assignment. In fact, one cool thing that you will probably experiment with later this semester is, let's assume that we have two variables, A is 1 and B is 2, and you want to swap them. In Java or any other programming language, you will have to create an extra variable, t, temporary, that it takes the value of A, so we can assign A to B, and then we can assign the value of t to B, to B. So in Python, you can do it as A, B is assigned. This is a multi-way assignment, B, A. And now A and B are swapped. So in fact, what we just did, we had two assignments at the same time. We took the value of B and we put it in A, and the value of A and we put it in B. Does that respond to your question, when would we use a tuple? Yeah, thank you, Daniel. Okay, great. So let's continue. List comprehensions. So list comprehensions are a concise way to create lists. And they basically use some keywords, for, if, and so on. So for instance, in this case, squares is a list of all the squares in the range up to 10. So the for keyword is used like a for loop, but is an expression, so it's not a statement. It basically computes x squared for every x in the range up to 10. It is the same with defining a new array, squares, and then for every x in the range up to 10, we add x squared to squares, but it's shorter, so its list comprehensions are a bit shorter. Let's do a few more experiments. Like for instance, if we want x multiplied with 2, for every x in some vector, we can basically use a list comprehension that returns every value doubled in a new list. Similarly, if we want to have an if statement, the order is exactly in the order that we read the statement. So for every x in vector, if x is greater than 0, then collect x. So in our example, because we had -4, -2, 0, 2, and 4, we extracted all the possible values greater than equal with 0, all the positive values. If we want to apply a function, like basically this is like a mapping, for every x in the vector, we want to compute the absolute value of x and put it in the new list. This can be done in a single expression by using a list comprehension. A list comprehension consists of a bracket, of a set of brackets consisting an expression followed by a for clause, then 0 or more other for clauses or if statements, or if clauses. The result will be a new list resulting from evaluating the expression in the context of the for and if clauses which follow it, and basically we can combine the elements of two lists if they are not equal. So let's assume that we have two lists, 1, 2, 3, and 3, 1, 4, and we want to create all the Cartesian product of the elements in the first list with the second list if the element is different, the two elements are different. So I will collect all the tuples. XY for every x. Somebody is trying to activate their microphone. Please don't do that because I hear myself back. We want to collect all the tuples xy for every x in 1, 2, 3, for every y in 3, 1, 4 if x and y are different. And we can see that it returns a list of tuples. Any questions up to now? No. Okay, good. Let's see more examples. So let's assume what basically this is just an example similar to the previous one that we saw. How is it actually implemented? We can see that if internally what it does, it's a for loop followed by an inner for loop followed by an if statement and an append. So the order in which we have the four elements is exactly the order that we have the execution. So maybe it will help to see an arrow, the fact that we are basically evaluating this from left to right. And this is important for the collection of the elements. Maybe I can make this arrow a little bit bigger. And of a different color. Okay. Okay, so if we want to create a list of tuples, we basically can create this list of tuples using the same variables. This is similar to the previous example. We have a lot of such examples. If we want to extract for every row in a matrix, and for every number in those rows to extract the numbers, which is basically flattening a matrix, we can do it easily with list comprehension in Python. Okay. So vector is in fact a matrix, and for every row in that matrix and for every element in that row, we basically extract the elements out. We can do much more complicated expressions. We can have, in fact, in the expression itself, a list comprehension. So for instance, if we want to transpose a matrix or to invert a matrix based on the main diagonal, we can basically do it as a list comprehension. So what the next expression does, for every I in the range of the length of the matrix, which is the number of rows, it executes the inner list comprehension. It basically returns row of I for every row in the matrix inside a list comprehension. So we iterate over the indices of the rows, and for every row we extract the element at that index. So for this square matrix, in fact, what we just did here with two list comprehensions, but the inner list comprehension is executed multiple times. For every index we actually execute the inner list comprehension. We basically transpose the matrix. So you can see that in the original matrix we had 1, 2, 3, 4, 5, 6, 7, 8, and now we have the columns 1, 5, 9, 2, 6, 10, and so on. So the outer comprehension evaluates like an outer for loop, and the inner comprehension evaluates as an inner for loop. The reason why I don't put this for after the first for loop is because then we don't get a matrix. We actually have to have an inner comprehension to get the inner lists, inner rows in the new list. Okay. This is a little bit more complex example. I want to make sure that everybody understands it. Any questions in the chat? Actually, is this new for anyone here? Because this is usually not something that you will see in Java. Okay, so a few of you responded yes. Thank you. Okay. Also, Python has logic embedded in it. So, for instance, if you want to check in an iterable object if all elements are true, or if all the conditions applied to those elements are true, or for any of them is true, you can use the two functions all or any and any. So all iterates over the collection, and for every element, if it's not true, it returns false. If this was not the case for any one of the elements, then it returns true. And similarly, any is implemented as for every element in the iterable. If the element is true, then we return true, otherwise we return false. It basically means that if at least one is true, we return true. And they are very useful because you basically can write very complex expressions. Like for instance, if you want to check in this example that all the elements in a range are prime numbers, you can do it with all and any. So again, the requirement is that what you are passing to all and any are actually iterable objects. They are not real elements. They are not a list of booleans, but they are actually iterable objects. So let's take a look at this example. So an element is a prime number if it's equal with 2 or if the element is less than 1, it's false, or if the element is now multiple of 2, but it was not 2, is false. Otherwise, we return true if for all elements, for all i's in the range from 3 to the element with a step of 2, element modulo I is different than 0. So you see basically what it does, it checks that condition, that element modulo I is not equal with 0 for any I in the range from 3 to the element with a step of 2. So now a use of any in the main function is the fact that we check that is it true that any one of the elements in this list is a prime number. So it calls the method is prime on x for every x in my list. So basically, you can consider that all is the universal quantifier in logic, and you can write logical formulas with all and any in Python. So as long as the inputs that you are passing to all and any, which are equivalent to universal and existential quantifiers, are iterable objects. Sets. So two more types that are very important in Python are sets and dictionaries. In fact, a set is just a specific case of a dictionary. It's a dictionary in which the key is the same with the value. So a set can be specified either by using the class set or by using the elements of the set within curly braces. Or you can get a set out of a list, or out of a list obtained from a list comprehension, or you can get a set as the characters of a string. So what can we do with sets? We can manipulate sets by basically adding elements to the set. We can get the length of the set, the number of unique elements in the set. We can get the maximum, minimum. We can get the sum of the elements of the set if the set contains numbers. We can check if an element is in the set. Is 3 in the set S1, we return false because the set S1 contains the elements 1, 2, 4, and 6. We can remove elements from the set, and then basically this is a mutable operation. It will modify the set by removing that element. We can check if sets are equal, and as you can see in this example, sets are unordered collections of elements. So 1, 2, 4 is a set equal with 1, 4, 2. Basically, equal it returns true, not equal returns false. We can check if a set is a superset of another set. So S1 is 1, 2, 4, and S2 is 1, 4, 5, 2, 6. Is S1 a super subset of S2? Yes, it's true because all the elements in S1 are also elements in S2. Is S2 a superset of S1? Yes, it's true. S2 is a superset of S1. We can also compare sets with the subset operators, or basically greater than, equal, which are basically proper superset or superset of, or less than, equal, and less than, which are subset and proper subset. However, these operators have special meanings for sets. They basically return true. S1 is greater than S2 if S1 is a proper superset of S2. S1 is greater than equal with S2 if S1 is a superset of S2. And similarly, S1 is less than S2 if S1 is a proper subset of S2. And S1 is less than equal with S2 if S1 is a subset of S2. Moreover, we can also have intersection and union and difference of sets. So union can be represented either by the function union, S1 union S2 returns a new set that contains the union of the two sets with unique elements, or you can use the vertical bar operator. Basically, it constructs the union of the two sets. Intersection is the AND operator or the ampersand operator. It constructs the intersection of the elements that belong to both sets. can be obtained either by the function intersection or the ampersand operator. Minus or difference is the difference between S1, those elements that are in S1 but not in S2. So 2 and 4 are in S1 but they are not in S2. They are returned as the result of S1 difference S2. If you want the exclusive difference of two sets, you can actually do the union of the two differences, S1 minus S2 and S2 minus S1. Dictionaries. So dictionaries are similar to sets, only that you have keys and values. So a dictionary can be created in the same way that you create a set with open close curly braces, or you can specify the elements of the dictionary as the key colon the value. So here we see an example: John with the value of 40, Peter with the value of 45. This actually may mean the age. John's age is 40, Peter's age is 45. You can extract the keys by using a for loop. For every key in the dictionary, we print a key followed by a string representation of the dictionary key, which is the value. So what we are actually creating here is dictionary of the key returns the value associated to that key. And since we are doing a concatenation of strings, we need to transform that integer that we had on the previous page with into a string. So dictionary of key extracts the key. Key in the dictionary checks every key in the dictionary. Moreover, in Python you can also create lambda expressions. We will see what lambda expressions are in SML, because SML is basically a functional programming language that contains anonymous functions. Anonymous functions are basically functions that we create on the fly. We specify what is the output for any given input to that function. So for instance, the incrementer with n returns a lambda function of x. For every x, it returns x plus n. So let's assume that we want to make a new function, f, that is an incrementer with 42. This is a new function, and in fact, if we print that function, it will tell us that for any given integer, it returns, or number, it returns a number. And that number is actually the original number plus 42. So f of 0 would return 42, f of 1 would return 43, and so on. In fact, you can even pass parameters. You don't always need to return functions. You can pass functions as parameters to other functions. So we are actually going to implement later this semester a parser using Lex and Yak that we can implement with lambda functions. In fact, the lecture notes that I have and I will use, they actually implement a simple parser that uses lambda expressions. We can import the operating system functions. There are a lot of standard libraries. We are going only to overview some of them. You can actually run a lot of the methods that you may be familiar with from Unix and any kind of Unix-based operating system. Like PWD stands for the current directory or the current working directory. You can get os.get CWD. It returns what is the directory, that current working directory. You can run any system command like make directory today or dir or anything that basically modifies or returns a value from the operating system. You can even run executables with os.system and the executable that you want to run. There are also a set of functions that are available as Python functions, like in shutil. These are operating system interface functions. You have functions for copying files, for moving directories and files, and so on. You also have regular expressions. If you import RE, you can actually find every occurrence of the regular expression that we have above. A white space followed by a word in the string which foot or hand fell fastest. And this extracts all the words that starts with F. So foot, fell, and fastest. Math.random, we already saw it before. We used it for shuffle, for shuffling a list. You can also extract elements from a list with random.choice. You can sample from a range any number of elements. In this case, I'm sampling from a range 100, 10 elements. Or you can obtain a random value between 0 and 1, including 0, not including 1 as a float, which is random.random. Statistics is another library that is popular in Python. You can compute the mean of a list, the median, and the variance of a list. These use standard mathematical definitions. You can also access websites, like for instance, from the URL lib, you can import the request URL open function, and with that URL open, you can print every line of HTML on the cs.stonybrook website. So basically, it's the same set of functionality that you are familiar from standard libraries like curl in Python, or in URL lib is in Python. Like curl is standard C library for web basically development. You can get the current date and time from datetime. You can subtract dates, and basically you can get the number of days, hours, minutes, seconds between any two dates. You can archive files and compress and decompress files or strings. You can compute other functions like CRC, which is a standard hash function. Okay, what is more important, you can actually do testing with Python, standard unit testing. So the doc test, which is basically part of the Python doc, it scans a module, and for every line in the doc, the method doc that starts with 3 greater than arrows, that is basically a command that will be ran in Python. So it will run the printing average, and then it will compare that the value that will be printed in the output stream is exactly the one that is specified on the next line. So for that, you can import doc test, and then in order to test your program, you can call .text mode, which automatically validates all the embedded tests. There is another library called unit test, which is a comprehensive set of tests to be maintained in a separate file. So for every function, like we had average in the previous example, you will implement, like in Java, a function called test underscore the name of the function, in which you call the original function average with the expected output. So this is very useful if you want to basically write, in addition to your functions, unit tests for your entire programs. Logging, this is similar to log4j in Java. You import logging, and then you have 5 levels, 6 levels of debugging information. Debug, info, warning, error, critical, and no set. Basically, you can log messages to the command prompt or to a file for basically debugging information. When you develop large programs, you want actually to have some kind of logging, maybe to a file, even in the distributions that you will make to customers. What else? Python is huge. There are hundreds, if not thousands at this point, of built-in functions, collections, and many more. You must install, in many cases, the pip, which is the Python installation module, to specify other packages like Django and Six. And you can basically install any kind of additional libraries and virtual environments in Python. If you want to read the Python reference language, the syntax and the core semantics are linked from the lecture notes. And this is our fast track course on Python. Thank you. And at this point, we will take questions, and we will record the lecture for your colleagues Based on your request, maybe we'll also post it on YouTube, so you can watch it later, you can download it and so on. So, any questions? I will stop the recording and then we will start a different programming language called SML, which is a functional programming language, but I will take a 5 minutes break because we just finished more than 2 hours of lecture.